Hello, third graders. I'm excited that you're here to learn with us today. We're going to be looking at some multiplication strategies. My name is Mrs. Gessley, and I'm the elementary math coordinator for Spokane Public Schools. Some lessons you will need paper and pencil, and some lessons we will just use our brain. It's always a good idea, though, to come to class with some paper and pencil just in case you need it. Today, we are going to be learning more about groups and using the array model to solve problems. Let's do a warm-up. How many Skittles do you see in my picture right here? I like Skittles, and so I decided this picture would be a fun one to use. Well, I'm wondering what kind of strategies did you use? Did you maybe look at how many red ones and then orange ones and then yellow? Or did you see and maybe say, oh, I wonder if I can count one by one? How did you solve that? Because then we also have this little part right here, don't we? That's empty. How many did you get? Let's see. Here's what I would do to solve this. First of all, I would see how many Skittles were in one column. I would count the red ones. How many red ones do you see? I see 6 red ones. And then when I look across the other way, when I look across this way, how many are in the other side of the box? 1, 2, 3, 4, 5, 6. So I know that there's 6 going across the top. If I had one of each color, there'd be 6. Well, if I know that there's 6 rows and 6 columns, that means that there's 6 sixes, right? And if I know my sixes, if I can count by 6, 12, 18, 24, 30, 36. Now I have one little problem. Do you remember? What about this right here? There's 1 missing. So I would subtract one of the purple ones to get 35. Is that what you got? Let's move on. All right, this is kind of a quick image. How many groups of dots do you see? And how many dots? All right, did you say that you saw 5 groups of 4 dots? So here's 1 group, 2 groups, 3 groups, 4 groups, 5 groups, 5 groups of 4 dots. So how many total dots? If you said 20, you are correct. This one's a little trickier. How many groups and how many dots all together? Do you need to see it one more time? That one's kind of a tricky one. Let's look at it again. All right, you could have looked at this one a little bit different than others. There's multiple ways to look at this one. When we look at it, how many groups, how many dots are in a group? Did you say 4? 4 dots in a group? If you did, you are correct. Now, how did you figure out how many dots? Well, when I looked at it, I said, oh, here's one group of how many dots? 8, which is really 2 groups of 4. And here's another 2 groups of 8, and another 2 groups of 8, and another 2 groups of 8, and then one more left over. So if I look at that way, I might say that there's 4 groups of 8, which, if I think about that, that's 32 plus 4 more equals 36. Or you could have looked at it like this, where you said 1, 2, 3, 4, 5, 6, 7, 8, 9 groups of 4, which equals 36. Does it go to the same answer both ways? It sure does. Those dots were kind of fun to look at, weren't they? We're going to transition now and figure out how to use some of those groups of numbers to figure out harder problems. Let's go. All right, here's our next one. What is 3 times 10? Well, if you know that 3 times 10 is 30, because that's 3 sets of 10, let's take a look. If we were to make a column and we were to say that this side is 3 and this side is 10, we know that that's 3 tens, right? We could draw these little lines here and say that there's 10 here, 10 here, and 10 here, which makes 30. So if you said that 3 times 10 equals 30, you're correct. But here's our next number. What is 3 times 9? Well, I'm wondering if I can use part of this picture that I drew here for 3 times 9. Well, let's take a look here. Here, let me do this. So if I know that there's 3 here, and then we decided that this whole section here was 10, and I take away one set of, what is this again? Each one of these is 3. If I take away one set of 3, 3 times 9 is 30 minus 3, which is 27. So this part here is 27. And let me see if I can help make this a little more clear. This here is 9. So if I know 3 times 10, I can find out 3 times 9 by taking away a group of 3. All right, are you ready to try another one? What is 10 times 8? I'm going to make that box again, and I'm going to make it a little bit bigger because we know that we have groups of 8 on the side and 10 on the end. So what do we know? We could count by tens, 10, 20, 30, all the way up to 80. Or you might just even know that 8 times 10 is 80. But here's our next one. What is 9 times 8? Can you use what you know about 10 times 8 to know what 9 times 8 is? Well, we know that 10 groups of 8 is 80. And so what is 9 groups of 8? So what happens if I take a group away over here, and now my new box is 9 groups of 8? How much is this shaded in spot for? We know that's a group of 8, isn't it? So what is 80 minus 8? Did you come up with it? If you said 72, you are correct. So 10 groups of 8 is 80, and 9 groups of 8 is 72, which is a subtraction of a group of 8. All right, third graders, are you ready for this one? 10 times 7. If we think about 10 times 7, what do we get? If we know that there's 10 down here and 7 over here, what did you get? If you got 70, you are correct. Here's our next problem to go with this one. It gets a little trickier. What is 9 times 7? Well, if we know that 10 groups of 7 is 70, and we want to know what 9 groups of 7 is, what is 9 groups of 7? We're going to take one away here because we want to know how many 9 groups of 7 is. So if we're going to take away 7, what do we get? Did you get 63? If you did, you are correct. All right, let's try a couple more and then we'll be done for today. Let's look at 10 times 11. So if we're looking at 10 times 11, our box is going to be pretty close to the same size, isn't it? One side's going to be a little bit longer and one side's going to be a little bit shorter. Now, as I was writing that, did you come up with what 10 times 11, 10 groups of 11 is? What about what 10 groups of 10 is? Did you come up with 100? 10 times 10 is 100. And if we added one more group, that would be 11, 110, right? 110. So 10 groups of 11 is 110. Well, let's try our next one. Are you ready? I'm going to give you a minute to think about it. What is 9 times 11? So we're going to take away one group of 11, from 10 groups of 11 to 9 groups of 11. Let's see. So this 9 groups of 11 means that I'm going to say 110 minus 11 equals, did you come up with 99? If you came up with 99, you are correct. Sometimes it's helpful to go to a friendly number that you know and then take away a group to find your next answer. All right, third graders, here's a picture to take with you. How many containers of dentine ice do you see? What do you think? It's a little tricky. How many are in one box? Here, I'm going to circle the way I kind of ended up looking at it. If I look like this at this one set of boxes, how many are there? Well, 1, 2, 3, 4, 5, and this would be 6, wouldn't there? So there's 5 in that one. How many in this one? In the second box over, set of box? Did you say 4? So 6. Let's see here. Let's see if we can keep track. If you said 6 plus 4, how many in this one? Plus 5. And how many in this one? 5. Oh, 6 plus 4 plus 5 plus 5. Well, if I was going to do that mentally in my head, I would probably look at these two and say 5 and 5 is 10, and 6 and 4 is 10. So what's 10 plus 10? 20. So if you came up with 20, you are right. This week, when you look around your house, look for things that are in groups. Think about eggs, or think about when you make cookies. Look up things that are in groups and try to find 2 or 3 things that you can point out to a sibling or to a parent. Have a great day, third graders. Hello, third graders. We're going to be looking at the second section of this lesson on some sidewalk chalk math. How many of you have some sidewalk chalk that you could use on your sidewalks? All right, third grade, here's our first challenge. You can find additional challenges at bit.ly MathWalks 2020. Here's our first one. What number am I? Our first clue is my value is even. That means that this number here is going to have to be even. The sum of my digits, so h plus t plus u, the sum of my digits equals 12. H is 2 times t, and the sum of u, so u equals h plus t. Do some thinking. Let's see if we can come up with an answer. All right, did you come up with an answer? Well, I'm going to start with, I know that this has to be an even number. So I know it has to be a 2, 4, 6, 8, it has to be an even number. And I know that the sum of my digits is 12. So what are some things that equal 12? I'm going to start there. So I know 6 plus 2 plus 4 equals 12. I could also say 4 plus 4 plus 4 equals 12. I could even say 8 plus 3 plus 1 equals 12. Those are some things that equal 12. The sum of my digits, so that one. Then h, so if we look at h is 2 times t. So t, if I look at one of these and I say t times 2 equals h, I'm wondering which one. 6 times 2 is 12, so that can't work. 4 times 2 is 8, and there's not an 8 there. 2 times 2, so h is twice t. So if t is 2 and I times it by 2, that's 4. Would that work for h? Let's try that. Let's see if 12 plus h, which is h is twice t, so h is 4, t is 2, and then u, this last one here, is the sum of h and t. So h and t, 4 plus 2 is 6. Does that work? Does that work where we have 12 equals 4 plus 2 plus 6? So is my number 426. Let's see, let's go through and make sure we have it right. U, the ones digits or the units digits, is 6. Is that one even? Yep, sure is. The sum of my digits is 12. Yep, we checked that. H, the hundreds place, is twice T. T times 2 is 4. Yep, that one works. And U is the sum of H and T, 4 plus 2. I think we got ourselves an answer. You ready for another one? All right, third grade, these are a little trickier. Let's take a look at this. What fraction of the space is occupied by each of the 3 patterns? So they're asking us to kind of look at some fraction pieces. I'm going to split these up for this time, and we're going to look at fractions, kind of separate out the fractions a little bit. How about we do that? So we have, if we look at this, we have like 6 spaces, right? Or we could say 3 columns. All right, the question is, what fraction of the space is occupied by each of the 3 patterns? So I might first say, I wonder how much space is occupied by this one. How much space of the whole is occupied by that one? Then the next one I'm going to go to is maybe these ones. How much space is occupied by those? And then we could also look at this one. How much space is occupied by this one? I have a question for you to think about before we go to the next slide. Is this shape and this shape, does that occupy the same amount? All right, do some thinking. We're going to look at it in the next slide. All right, third graders, what should we start with? Let's go ahead and maybe start with thinking about if we look at this as a whole, that's 1, right? The whole is 1. Now, if we look at this one, let's do this, and I do this, and I'm going to go ahead and do that here too. So if we look at how many spaces we have when we split it like this, we have 1, 2, 3, 4, 5, 6. So if I'm wondering how much of this one is, how much is shaded in there, I have 1 out of 6. So that would be 1/6 shaded. Well, if that's true for that one, I'm wondering if that is also true for this one. 1/6. So both of those shapes are 1/6. Now we get to this next shape, which now we're trying to kind of figure out this, right? So we need to figure out how much is that one. Let's go to a new slide and test out that one. All right, third graders, we have one section left. We're trying to figure out how much of this total shape these 2 little pieces are right there. Well, let me redraw that little shape right there so we know that it looks like this, right? So there's how many parts in that shape? There's 1, 2, 3, 4. And if I draw 2 more sections of that to equal this whole section, and there's 4 parts in that one and 4 parts in that one, how many parts do we have total? So 4, 8, 12. So we have 12 parts, so that's what goes on the bottom. And how many shaded in of the 12 parts? We have 1, 2. So we have 2 parts out of the 12. Is that what you got? You could have also gotten 1 part out of 6, because you could have said these are together equal 1 part out of 2, and 1 part out of 2, and 1 part out of 2, so 1 out of 6. So you could have said 1 out of 6. These were pretty fun, weren't they? All right, that's the end of our lessons for today. We've had some fun, haven't we? Go to bit.ly MathWalks 2020 for some additional challenges. There's some for your older siblings and for younger siblings and for even parents. I hope that you've enjoyed the lesson today on KSPS. Come back next week for some more lessons.